Okay, so we're moving on now to histograms. And a histogram, the difference between a histogram and a group frequency diagram is that in a group frequency diagram, the frequency for each interval is read off the vertical axis. So if you had a bar there going up to 2, that would represent 2 people or 2 data items. With a histogram, it's the area of the bars that represent the frequency, and what you're actually plotting vertically is known as the frequency density. Histograms are used when the intervals that you are working with in your data are not all the same length. The gaps are different. So you can see in this one here, the first interval there has got a gap of 40, the next one's got a gap of 10, the next one's got a gap of 5, and so on. So the way that we deal with these is, first of all, you have to work out what that class width is, okay, which is what we call it. So if I add an extra column here called class width, we'll see the first one has got a width of 40, as I mentioned just now. The next one has got a width of 10, then 5, then 5, then 5, then 5, then 20. We calculate the frequency density by dividing the frequency by the class width. So this frequency density is going to be 0 divided by 40. Then we've got 3 divided by 10, 5 divided by 5, 15 divided by 5, 25 divided by 5, 10 divided by 5, and 2 divided by 20. And then, to draw the histogram, we plot the classes against the density. So the first one there, between 0 and 40, would be 0, and then between 40 and 50 is 0.3. So we're going from 0 to 1 in 10 jumps, so each one of those is going to be 0.1. So between 40 and 50 is 0.3. Then between 50 and 55 we go up to 1. Then between 55 and 60 we rise to 3. So I'll get using the ruler now. And then between 60 and 65 it rises to 5. Between 65 and 70 it's back to 2. And then between 70 and 90 it's 0.1. So that's what that histogram looks like. Question 2. There are 100 pupils in year 9. The time taken by each pupil to answer a mental maths question was recorded. The following group frequency distribution was obtained. Find an estimate for the median of this distribution. Well, if there are 100 pupils, we're looking for where the 50th pupil lies within this data. So the median time will be for 50th pupil. Now, because the data is grouped, it's already put in order, so you know that the first 8 pupils got between 0 and 10. So the 8 and the 17, the first 25 pupils are between 0 and 20. So we've got 25 pupils there. The next 25 pupils are between 0 and 30. So there you've got 50 students. So the 50th pupil in order is likely to be take 30 seconds. Okay, so you've got 8, 25, 50 cumulative. So the 50th pupil is likely to be close to 30. And it's an estimate, so our estimate is 30 seconds. Okay, for the histogram we need the class width and we need the frequency density. So the class width will be 10 for the first one, 10 for the next one, 10 for that one, 10 for that one, and 20 for the end one. So the frequency density will be 8 divided by 10, 0.8, 17 divided by 10, 1.7, 25 divided by 10, 2.5, 38 divided by 10, 3.8, oops, and 12 divided by 20, which is 0.6. So frequency density against these, so between 0 and 10 we've got a density of 0.8. Again, pretty shocking graph paper, but we'll get an idea of the shape of it. Between 10 and 20 it's 1.7. Between 20 and 30 it's 2.5. Between 30 and 40 it's 3.8. Between 40 and 60 it's 0.6. So again, when you're doing that in the exam, you'll have decent graph paper, use a ruler, use a pencil, but that's the shape that you're likely to be getting. Okay, question 3. Pretty big question this. If you look, you've got 3, 6, 7 marks for this question, so if you can get your head around this, then you can score highly. As part of an investigation, the time taken to undo 3 knots in a piece of string was measured for each pupil in a group of 12-year-olds. The histogram below illustrates the results obtained. Use the histogram to calculate the number of 12-year-olds in this group. So as I said at the start, the frequency isn't given by the height of the bar, it's given by the area of the bar. So we can work out here that this area is 10 times 3. So that bar represents 30 students. The next bit is going to be 10 times 4, 40 students. 10 times 5, 50 students. 10 times 4, 40 students, and here we've got 20 times 1. 20 students. So the total number of 12-year-olds is going to be 30 plus 40 plus 50 plus 40 plus 20. 180 students. 180 12-year-olds. Part B. The time taken to undo 3 knots in a piece of string was measured for each pupil in a group of 216-year-olds. The following group frequency distribution was obtained. Find an estimate for the median. So this was like we did in the second question. This time the median is going to be the 100th student. Because there are 200. So if we work with the cumulative, we've got 45 of them there. We finished in less than 10. There's 55 of them finished between 10 and 20. So that means there are 100 of them lined up finishing between 0 and 20. The 100th student is likely to be pretty close to 20. So likely to take 20 seconds. So our estimate is 20 seconds. Now we're going to draw our own histogram. So first of all, the class width. First one is 10, the next one is 10, the next one is 10, then 10, and the last one is 20. So the frequency density is going to be 45 divided by 10, 4.5, 55 divided by 10, 5.5, 60 divided by 10, 6, 30 divided by 10, 3, and 10 divided by 20, 1.5. So we're going to go to 4.5 between 0 and 10, 5.5 between 10 and 20, 6 between 20 and 30, 3 between 30 and 40, and half between 40 and 60. So histogram is going to look like that. It's then asking us, state with a reason which of the two groups is better on average at undoing knots. Well, you can see there the modal for both of them is, bring that back in, between 20 and 30, so the modal isn't that helpful. But what we can see is that with this group here, the group taking longer than 40 seconds is 10 out of 200. Okay, so for 16-year-olds, we got 10 out of 200, 5% take longer than 40 sec. Okay, and here we've got 20 out of 180. Okay, 20 out of 180 is 11% take longer than 40 seconds. So on average, the 16-year-olds are better. Number 4. Okay, so context of this is it's a survey carried out to measure the lengths of gardens of a number of houses. The histogram shows the results. Use the histogram to calculate the number of gardens measured. So the first bar is going to be 10 times 2. The second bar is going to be 10 times 4. Then we've got 10 times 3.5 and 20 times 1 point, that's going to be 1.25. 20 plus 40 plus 35 plus 20, that's 1.25, 25 plus 35 plus 40 plus 20 equals 120. Now, this is another little twist again. Find the length exceeded by 50% of the gardens measured. So we need to see where the dividing line is, splits the area of that 50-50. Now, if there are 120 gardens, then 50% of 120 would be 60 gardens. Okay, now we know that that's 20 and we know that that's 40. So 50% of the gardens, there's our cut-off. Okay, 50% that side, 50% that side, because we know that 50% is 60 gardens. First 20 are there, next 40 are there, so the first 60 are there. So the length exceeded by 50% of the gardens is going to be 20 meters. So 50% of gardens longer than 20 meters. Let's try to make that clear again. So we've worked out that each of these bars, what the frequency is that is represented. So there are 20 gardens, 20 homes in there with gardens up to 10 meters long. There are 40 homes in the next rectangle, so there are 40 homes between 10 and 20 length gardens. So there are 60 homes with gardens between 0 and 20 meters long. 60 homes or 60 gardens is the halfway point. Question 5. Use the histogram to calculate the number of driveways. So the context here, a survey was carried out to measure the lengths of driveways to a number of houses. The histogram shows the results of the survey. Right, so we need to work out the areas of each of these rectangles. So the first one is going to be 2 times 3.5. The second one is going to be 2, 4, 6 times 2.5. The next one, 2, 4, 6, 8, 10 times 3.5. 2.2, and the last one is 2 times 2.6, 2.5. So we have 7 plus 15 plus 32 plus 5, so that equals 20, 52, 59 driveways. Find the length exceeded by 75% of the driveways measured. So just like with that last question, we were looking for the dividing line 50-50. Now we're looking for the dividing line 25-75. Okay, and it's the distance exceeded, so we want the 25% dividing line down here. So 25% of 59 14.75. Okay, so I need to find out the position between the sort of 14 and 15 driveway. I know there are 7 in there, and I know there are 15 in there. So somewhere in between there and there is what I need to work out. Okay, I need to know that if there's 7 in there and I'm looking for 14, I'm looking for another 7.75 in there. Okay, and that's going to be my dividing line then between the 25% and the 75%. Okay, so what I'm working out here is that and that has to add up to 14.75. I know there are 7 in there, so I'm interested in this rectangle here. What I'm trying to work out, if I can just sort of pull that out of there, this rectangle here I know has got a height of 2.5. I know it's 2.5 high. I want to know how wide it is to give it an area of 7.75. So 2.5 times x is 7.75. So x is 7.75 divided by 2. So it's 3.9. So I know that to the distance that I'm looking for here is going to be, it's 0 to 2 to there, and then it's an additional 3.9 in. So length of driveway exceeded is going to be this distance in there, which is going to be 2 plus 3.9 equals 5.9 meters. So the actual dividing line between the 25% and the 75% is 5.9 meters, which is actually further in there. So it would be this region there. That is pretty difficult to get your head around. If you crack that, you've got nothing to worry about with histograms. I'll go through it again. I know we got 59 driveways. I'm interested in the dividing line between 25% of them and 75% of them. The 25% dividing line is going to be 14.75 driveways. Okay, I know you can't have that, it's going to be 14 or 15, but we're working here with estimates. So I'm looking for the area there which represents 14.75. I know that the first area represents 7 driveways, which means I'm then looking for another 7.75 of this rectangle in order to make that up to the 14.75. I know that the strip I'm dealing with has got a height of 2.5. I know what its area has to be, and I've got to work out what the width is. So 7.75 divided by 2.25, 2.5, that should be, hold on, I got wrong there, divided by, write that again, 7.75 divided by 2.5 equals 3.1. So I know that that distance is 3.1. So the length of the driveway, I know it's 2 from there to there, and I know I have to go in another 3.1. So the dividing line is 5.1 meters. 25% of the homes have a driveway 5.1 or less. 75% of the homes, the driveway is longer than 5.1. That's a tough one. Okay, then we've got one left to do, which is on larger paper, so I'll just zoom out. Wrong way. Okay, so histogram below represents the results of gathering and measuring the length of twigs. Use the histogram to complete the group frequency table below. So between 0 and 20, that's going to have an area of 20 times 4, which you can't see if I write it there, so I'll write it in here. So that's going to be 20 times 4, which is 80. The next one is going to be 10 times 5, which is 50. The next one is going to be 10 times 7, which is 70. Then 10 times 6, which is 60, and 20 times 2, which is 40. Find the fraction of twigs that are 40 centimeters or longer, expressing your fraction in its lowest terms. So 40 centimeters or longer is going to be those two, which is going to be 100 out of how many twigs there are altogether. So that's 80, 130, 200, 300. So it's 100 out of 300, which is 1/3. Calculate an estimate of the number of twigs with length less than 22 centimeters. So 22 centimeters is going to be 20, take us up to there. So we've got that rectangle there, which is going to be 20 times 4, plus this shaded rectangle here, which is going to have a width of 2 and a height of 5. So that's going to be 80 plus 10, 90 twigs. less than 22 centimetre long. So on the whole, histograms, pretty straightforward. It's just dealing with areas rather than heights. The only time it gets a bit complicated is when you're working with fractions or percentages or parts of the bars. But most of it is really accessible.